Okay, now, question C34, October 2017, International A-Level, a question about vectors. Question number 12. Relative to a fixed origin, O, the lines L1 and L2 are given by these equations, where lambda and mu are scalar parameters. The lines L1 and L2 intersect at point A. Write down the coordinates of A. Now, this is worth 1 mark and it says write down. So there's something to this which, you know, if you don't see it straight away, you should say, hold on a second, why is it only worth 1 mark? Because if you want to find where lines intersect, normally it's a bit more hassle because you got to make the lines equal to each other and then you got to try to form some equations and whatnot. But if you notice here, these two are exactly the same. And what these two represent are position vectors on the line L1 and L2. So they're both expressed with the same position vector. So they have the same, if that's O, and that's the point A where they intersect, one line might be going like this, and the other line might be going like that. We don't know how they're going, but yeah, it's 3 dimensional, so we can't really draw very easily, kind of like accurately, but that would be A, and that would be, say, line 1, and that would be, say, line 2. So that represents the direction that they're going in. But this represents a point, okay, relative to the origin. So this represents the vector from O to A. And you can see this also represents the same vector, O to A. A is where they intersect, so that's the same point on both lines. So that must be the point A. So the coordinates of A will be 2, 0, 7. You should write it in coordinate form, not in vector form. Okay, because the coordinates of A are going to be, you know, the same numbers. That's a vector from O to A, but in coordinate form. Okay, that's the x coordinate, the y coordinate, and the z coordinate. Okay, that's why it's only worth 1 mark. You don't have to really do any calculations there. Okay. Oh my God, what did I do? 1 second. Oh my God, what did I do? Hold on, something just disappeared out of nowhere. Where did it go? Oh wow. Okay, I don't know how that happened. Sorry about that. Okay, it came back again. The question ran away from us. Okay, so now we've answered part A, now we're going to do part B. It says, given that the acute angle between line 1 and line 2 is theta degrees, show that sine theta equals k root 2. Okay, so what I'll do is I'll just, I'll take that diagram. Okay, I'll do it by doing this. Little trick I have here. I'll take this diagram. Okay. Copy and paste. I'll put it down here. Put it over here. Okay, so I'll draw it again. Okay, so that's like a diagram to represent our vectors. Of course, it's not accurate, but it doesn't have to be. So let's say line 1 is going in this direction and line 2 is going in that direction. It says the acute angle between line 1 and line 2 is theta degrees. Show that sine theta equals k root 2, where k is a rational number to be found. Okay, so basically we know that the dot product of two vectors is equal to their magnitudes, the product of their magnitudes, times the cosine of the angle between them when they are tail to tail. Okay, so if this is line 1 and this is line 2, okay, line 1, okay, this is its vector. Okay, so this is the vector, this is the position vector, and this is the direction vector. So the line 1 has a direction of 2, minus 2, and 1, and that's what we're interested in terms of its direction. We're only caring about the direction. So A is like for line 1, let's say, and B is like for line 2. Okay, so B is going to be this direction, 841. 8, 4, 1. So when I find the dot product of these two vectors, okay, the dot product of these two vectors, so I've got 2, minus 2, 1, dot product with 8, 4, 1. Let me make sure I haven't made a silly mistake with the signs. No, there's no negative in that one. Okay, that should give me the magnitude of A times the magnitude of B times the cosine of the angle between them. So the magnitude of A is 4 plus 4 plus 1. That's 4 plus 4, 8 plus 1, 9. And the magnitude of B is 64 plus 16 plus 1. 64 plus 16 is 80, that's 81. Okay, that's working out to be quite nice, isn't it? Okay, so the dot product of these two vectors is 2 times 8, which is 16, plus minus 2 times 4, which is minus 8, plus 1 times 1, which is plus 1. And that's equal to, that's 3 times 9 times the cosine of theta. So 16 minus 8 is 8, plus 1 is 9. So you end up with 9 equals 27 times cosine theta. So therefore cosine theta is 9 over 27, which is 1/3. Okay, 1 over 3. Okay, so let's just confirm that. That's 4 plus 4 plus 1, 64 plus 16, 74, 80, 81, that's right, okay. And 6, that's 16 minus 8 plus 1. 9, okay, good. So cosine of theta is 1 over 3, okay. So show that the acute angle between line 1 and line 2 is theta. Show that sine theta equals k times root 2, where k is a rational number to be found. So if cosine theta equals 1/3, we want to find what sine theta is, okay. So there's no need for us to find the angle, but what we can do is say, okay, let's make a little diagram of cosine theta, okay. So what we found here is we found the ratio for the acute angle between the two. Yeah, that's going to be an acute angle because it's in the first quadrant. It's positive. A, S, T, C. Cosine is positive in the first and the third quadrant. This is a positive ratio, so it's going to be the acute angle, which is going to be the angle when they're tail to tail. That's fine. So we've got theta here. The cosine of theta is 1 over, adjacent over the hypotenuse, 1 over 3. So this is going to be the square root of 3 squared minus 1 squared. So that's 9 minus 1, which is 8. Okay, so that's going to be the square root of 8. Okay, so, and the square root of 8 in its simplified third form is root 4 times root 2, which is 2 root 2. Okay, so it's looking good so far. We got root 2 there. And so we know the sine of this angle, the sine of the angle is opposite over hypotenuse. So it's going to be 2 root 2 over 3. So we can see that sine theta is equal to 2/3 root 2. So we can see k is 2/3. Okay, so that's that done. Now I think I need to take this down here. Okay, so now part C, the point B lies on L1 where lambda equals 4. Okay, the point C lies on line 2. Okay, so I'm going to actually make a new diagram. Say that's line 1 and say that's line 2. Okay, we know this is the point A where they intersect. Okay, the point B lies on line 1 where, say this is where point B is. Okay, say this is line 1 and this is line 2. Okay, they intersect at A. The point B lies on line 1 where this is where lambda equals 4. The point C lies on line 2 where A such that AC equals 2 times AB. Okay, so we don't know which side it is, but it doesn't really matter because we're only concerned about finding the area. So AC could be, C could be on either side. Let me say C is over here. Okay, so I know that this distance here and this distance here, this is double. So say this distance is x, this distance will be 2x. AC is twice AB. Okay, we've got to find the area of this triangle. Now we already know that this is the angle between them, theta, And we already know that the sine of theta is 2/3 root 2. And we know that the area of a triangle, if we don't know the vertical height, is a half times AB, which are two sides, times the sine of the angle between those two sides. So this is the angle between these two sides. Now, I don't know what the coordinates of C is, but I know what the coordinates of A and B are, right? So they've said the point, we know the coordinates of A. So A is a vector, okay, A is a vector 2, 0, 7, because that's where they intersect. That's a position vector of A, okay? And the position vector of B can be found because it's where lambda is equal to 4. So we can say the position, that's O, this is O to A. How to get to O from A? How do we get to B from O? Well, that's going to be when I put lambda equals 4 into this vector. So when I put lambda equals 4 into line 2, I'll get O to B, which will be 2, 0, 7 plus mu times 8, 4, 1. Okay, so that gives us a mu, sorry, not mu, sorry about that, haven't slept all night. That's line 1, and it's the other equation, line 1, which has got the lambda in it. Of course, we've got to use the one that has a lambda in it, right? Because it's where lambda equals 4. So that's going to be lambda, which we already know is 4. So you've got 4 times this vector, which is 2, minus 2, and 1. Okay, so you have 2 plus 8, which is 10. And you have 0 minus 8, which is minus 8. Sorry, 0, yeah. So 2 plus 8, which is 10. 0 minus 8, which is minus 8. And 7 plus 4, which is 11. So that's the vector from O to B. Okay? And we need to find the vector from A to B. Okay, we need to find the vector from A to B. Then I can find the length of A to B. Okay, so I need some more space for this question. So I'm going to just carry on down here. Although really I should change over the page, but I want to see what's going on. So let's just carry on down here. I'm sure you won't mind. Okay, so we need to find the vector from A to B. Then I can find its magnitude. Okay, and I'll know what this length is. I can double that and I know what this length is, and then I can use this formula. So the vector A to B, how do we find it? Well, if this is A and this is B, and let's say this is O, how do I get from A to B? If I know what O to A is, which I do, and if I know what O to B is, which I do. Okay, from A to B is, I have to go from A to O, which is like minus O to A, right? And then I have to add to that O to B. Okay, I have to go the opposite of O to A plus O to B. So that can be written as, that's O to B minus O to A. Okay, that's how it goes. You can picture it. I don't like it when things are just memorized without understanding. So this is 10 and minus 8 and 11 minus O to A, which is 2 and 0 and 7. You just got to be very careful about your signs. I'm sure I'm going to make a mistake because I'm really tired right now. Minus 8 minus 0 is minus 8, and 11 minus 7 is 4. So that is the vector from A to B. Okay, so I need to find its magnitude. I need to find the magnitude of the vector from A to B. Okay, and then I have the length of this line. I'm almost home and dry. So the magnitude of the vector from A to B is going to be 8 squared, which is 64, plus another 8 squared, which is 64, because when you square the negative number becomes positive, plus 4 squared, which is 16. Okay, and that gives you 128 plus 16. That's I say 80 plus 64. I think that's 144, isn't it? Is that 144? Let's just make sure. So we're going to have the square root of 8 squared plus 8 squared plus 4 squared. So if that gives me 12, yes, I was right. So that's going to give me 12. So nice numbers now. I know that this x here, this is 12. So this is 24. And I know what the sine of the angle is. It's 2/3 root 2. So we're sorted. We can find the area. So basically what you have is a triangle that's like this. We know that length. We know that length. We don't know that length. Okay, that's A. That's B. That's C. We know this is 12 units. We know this is twice that, which is 24 units. And we know that the sine of this angle is given by 2/3 root 2. So we know from the previous question that sine theta equals 2/3 times root 2. Sorry, root 2. Was it root 2? Root 3 was root 2. Yeah, root 2. Okay, so now we can say that the area of the triangle is going to be a half times the two sides, 12 times 24 times the sine of theta, which is 2/3 root 2. Okay, the sine of theta is equal to all of that. So the 12 cancels with the, let's cancel the 2 with this 12. Okay, 24 gives you 12. 3 goes into 12 4 times. So we're left with 48. We've got this 2 left, haven't we? Yeah, 48 times 2, 96 root 2. I'm just going to confirm that in case I made a mistake, because I'm a bit sleepy right now. So you have 0.5 times 12 times 24 times 2/3 times root 2. 96 root 2. Okay, let me write that neater. So the area is 96 root 2 square units. Okay, we're trying to be as careful as I can so I don't make mistakes here. I'm going to check the mark scheme before I upload it to make sure it's correct. So that's 96 root 2 square units. Now, part D, sorry. Find the coordinates of the two possible positions of C. Okay, so I thought that was coming. Now, we want to find the two possible positions of C. Okay, so what I'm going to do is this. Okay, I'm going to take this and put it on the other page. Let me just... Okay, so here we have the diagram and the information from the last parts of the question that we need. Okay, so basically, what we know is at this point, A, that's where lambda is equal to 0, and where also mu is equal to 0. We know B is where lambda is equal to 4. We were told that. Okay. We have to find the two possible positions of C. Well, I've already determined that C can either be here or here. We mentioned that before, so let's call that C dash. You can have two triangles which have the same vertical height, okay, and they'll give you the same area, basically. So C can either be 24 units this way, okay, because the length AC has to be twice the length BC. So it can either be that way or that way. So there could be Alhamdulillah. Sorry about that. Okay, so they can either be C1 or C2. That length can be 24 here, or that length can be 24 here, still twice 12, and this angle will still give you 2/3 root 2. So because it'll be, this is 180 minus that angle, and 180, the sine of 180 minus an angle is the same as the angle. So there's no problem there. Okay, so that area, the area of this triangle will be identical to the area of that triangle, which is our situation here. Now, one of the things we do know is we know that line 2, okay, the vector for line 2 is in the direction 2, -2, and 1. And we know that C is in the same direction as line 2. One of the C's is in the opposite direction to it, and one is in the same direction to it. So basically, we know the magnitude of AC. I know the magnitude of AC is equal to 24. And I know the direction of AC is the same as the line 2, which is 2 minus 2, 1. So I know the vector from A to C will have the magnitude of 24, but it will be in this direction. So what I need to find is the unit vector. I need to find the unit vector in the direction A to C. Okay, how do I find the unit vector? Well, I need to first find one unit in this direction. Okay, so let me take the magnitude of this. We already did. The magnitude of this was 9. It was 3. The magnitude of the vector for line 1, no, I won't put line 1. The magnitude for the direction of line 1, okay, is going to be 2 squared plus 2 squared plus 1. It's going to be square root of 9, which is 3. So the magnitude of the direction going in line 1 is 3. Okay, so if I do 1/3, the unit vector in the direction of A to C is going to be 1/3 times 2 minus 2, 1. That's 1 unit in the direction of A to C. Okay, I don't know how. So that is, so 1/3, 2 minus 2 and 1 is, say it's going this direction here. So that's 1 unit in that direction. That's just 1 unit in that direction. Okay, because we're going in the direction for line 2. Okay, the direction of line 2, okay, this particular vector has a magnitude of 3, because it's the square root of 4 plus 4 plus 1, which is square root of 9. So we're 1 unit in the direction, we're 1/3 of this vector. But we want 24 units in the direction of that vector. Therefore, the vector A to C, okay, is going to be 24 times 1/3 to 2 minus 1. Sorry, whoops, see, I'm going to make a mistake there. It's 2 minus 2 and 1. Okay, 2 minus 2 and 1. Let me make sure that wasn't a mistake from the beginning. It's right, 2 minus 2 and 1. And, I made a mistake. Okay, I'm going to keep this on the video because I have time to edit it out, but I made a silly mistake. Okay, let me just correct that. I didn't look at it properly. I said we want a unit direction in the line 2, and I wrote down the direction of line 1, and I would have got the answer wrong. Okay, so basically we know that C lies along line 2, so it's in this direction, 8, 4, 1. So we can say the direction of A to C is the direction of line 1, right? So therefore, that's in the direction 8, 4, 1. It's in this direction, but we do know its magnitude. This does not have a magnitude of 24. This has a magnitude, the magnitude of this vector 8, 4, 1, okay, is equal to the square root of, and I think it was 64 plus 16 plus 1, which is the square root of 81, which is 9. Okay, now that means 1 unit of the vector A to C is going to be 1/9 of 8 and 4 and 1. Therefore, the vector A to C is going to be 24 times. So 24 over 9 times 8, 4, 1. Now 3 goes into both of those, isn't it? 24 divided by 3 is 8 over 3. So you'll have the vector from A to C in this simpler form will be 8 over 3 times 8, 4, 1. Okay, that's the vector from A to C. But we want to find the coordinates of the two possible positions of C. So I want to find what O to C is. Okay, so remember, A to C is either this direction or in the opposite direction. So A to C could either be plus 8 root 3 or minus 8. Oh, so 8 over 3 times that vector, or minus 8 over 3 vector. See, when we did 8 over 3, when we did 1/9 of this vector, we found 1 unit in this direction, or that direction, it doesn't matter. Okay, whatever it's going to be. And when we multiplied it by 24, we found a vector which has a magnitude of 24 in that same direction. And if we find the negative of that, we've got a vector which is 24 units in the opposite direction. That's why you got plus and minus. Those give me the two possible positions of C. So O to C, okay, supposing this is O over here. Supposing this is O over here somewhere like this. Okay, so the vector from O to C, okay, is going to go like this. Oops, where's my line gone? The vector from O to C is going to go like this. This is from O to C, and this is from O to A. If I want to find the vector from O to C, which is this vector here, I need to go from A to O to C. I've got to go from O to A and then from A to C, right? From O to A and then from A to C. So same thing here, O to A and then from A to C. So one of them will be found. So O to C is like O to A plus O to C. So O to A is our original vector 207, where the two lines intersected. So we can say that O to C is going to be 207 plus or minus O to C okay, plus or minus, and then let's just do this. This is 8 over 3 times 8, that's 64 over 3. That's 8 over 3 times 4, that's 32 over 3. And that's 8 over 3 times 1, that's 8 over 3. Okay, so our vector from O to C will be, so O to C1 will be 2 plus 64 over 3. Okay, let's just do that in a calculator. We've got 2 plus 64 over 3. And we're going to have the O to C2. There's two possible ones. One is when you add that vector, and one when you subtract the vector. Okay, so you're going to have 2 plus 64 over 3, which gives you 70 over 3. Okay, and you're going to have 2 minus that as well, so I'll just do that in one step. Okay, 2 minus 64 over 3. That gives you minus 58 over 3. Okay, so that's one up here, that's one here. Minus 58 over 3. Okay, and then you got 0 plus 32 over 3. It doesn't, so that's 32 over 3. And 0 minus 32 over 3. That's going to be minus 32 over 3. Then you got 7 plus 8 over 3. So you have 7 plus 8 over 3. Seven plus 8 over 3 gives us 29 over 3 in this one. And 7 minus 8 over 3. So just put minus here. And that gives you 13 over 3 on this side. So here we have the two possible position vectors of C. Okay, but they want it in coordinate form, right? They said the coordinates. So we could say C1 has coordinates 70 over 3 and 32 over 3 and 29 over 3. And the coordinates of C2 are going to be minus 58 over 3, minus 32 over 3, and 13 over 3. Whew. Okay, that was a bit of a one we had to think. Took a bit of time, but we got there. Thank you.